Hey guys, welcome back to our channel. Today we are going to prove the NCR formula in an interesting and intuitive way using counting arguments and recurrence relation. So without any further ado, let's move towards the concept explanation. Before we begin, let me give you a basic idea between permutation and combination. Imagine you have went to a store and you are advised to buy all these fruits, and you had only one way to buy this: buying apple, then orange, then banana, and orange, then apple. It doesn't matter. An arrangement in which the order doesn't matter, which is called combination. And consider a new scenario in which we need to open this lock by changing these numbers. And if you take the numbers 273, and if we change this numbers order, example 723, let's say, it give rise to a new arrangement, an arrangement which is obtained by interchanging their order is called permutation. And summarize it bit, an arrangement which order matters is called permutation, and it doesn't matters called combination. Then we need to select R object out of n objects. We can do this job by selecting R minus 1 object first and selecting the remaining one object. Selecting R minus 1 object out of n object, which is n choose R minus 1, and selecting the remaining one object, which we can do this in n minus R minus 1, R minus object first, and remaining one object we can do it in n choose R minus 1 times n minus R plus 1. Number of ways we can select this object, but there is a catch here. For that, consider a simpler case where if we choose n as universal set, let's say A, which contains A, B, C, D, E, and the subset R is which is A, B, C, and then by principle we choose R minus 1 selection first and remaining one selection next after that. Then R has 3 elements, then R minus 1 selection have only 2 elements. If we choose 2 elements separately, let's say A, B first from R set, then automatically the last element become C only. And if we choose 2 elements, second possibility, which is A and C, then automatically the last element become B only. If we choose B and C, then automatically last element become A only. This means for 3 elements set, there are 3 duplicates are there. Then if we choose R elements there, then it must be R duplicates must be there, which means we have to divide by R to get the final answer. Then the recurrence relation magic will come. If we wrote the term n choose R, which is n choose R minus 1 times this term, and we observe the pattern. Let's say this term had R and this term had R minus 1, and this terms had n minus R minus 1. That bracket gets opened up, and if we take this n choose R minus 1 here and wrote in terms of n choose R minus 2, we subtract 1 from R minus 1. I ended up getting n choose R minus 2 times n minus R minus 1, then become n minus R minus 2 divided by R minus 1, which we can substitute this n choose R minus term in terms of n choose R minus 2. We substitute here, we can substitute here. Then but if we wrote n choose R minus 2 in terms of n choose R minus 3, then this term become n minus R plus 3 divided by R minus 2. Then if we continue this process till n choose R equal to n choose 1 times this, lot of the terms will multiply together. This is because we put each term here, then n choose 1 become n. Then doing little algebra and simplifying the terms, we ended up getting n choose r is, which is n factorial divided by r factorial times n minus r factorial.